The quantum revolution is coming, and 2026 can be a massive year in terms of the quantum computing capabilities. This is going to bring us massive challenges in terms of how we secure our data. Today we are exploring how we can actually build an IPSec tunnel that are resistant to advancement of quantum technologies and will be able to secure from attacks such as Harvard's now decrypt. As of today, we have seen that the smallest key ciphers are able to be broken through quantum technologies, and as we make advancements in terms of how the quantum computing works and also being able to reduce the noise or the errors that qubits generates, it will be in a matter of time that the large ciphers or the large key sizes will also be in threat. Now, to transition this, we are going to use a hybrid key mechanism where we'll be able to use ciphers that are resistant to be broken by the advancements of quantum computing. So, as we discussed earlier, the attackers are already harvesting data. We call them as harvest now decrypt attacks. So these are already capturing the encrypted communications that happens on the internet, and they will be able to leverage that the advancement of quantum in the future to break this traffic and get the valuable data. So this makes the transition to post-quantum ciphers an immediate priority and not something that we cannot afford not to do. So today we are going to use Palo Alto Networks Firewalls to build an IPSec tunnel that is resistant to these quantum attacks. And Palo Alto Networks has positioned itself as a key player in this transition. They have introduced multiple different features for visibility control and also to ensure that organizations are ready for the post-quantum era. So what we are going to do is, initially there was one other capability that came in the form of RFC 8784, where we use additional pre-shared keys to secure for the post-quantum ciphers. But there was a new advancement that happened where a couple of new RFC standards, RFC 9242 and along with RFC 9370, now we are able to derive hybrid keys that are resistant to these post-quantum attacks. So this enables us to build seamless IPsec tunnels even if we are already using pre-shared keys and the existing ciphers. We'll be able to add these new ciphers on top of that to derive hybrid keys where our communications will be secure. Now let's get to building of the two IPsec tunnels. For this, I'm going to use a PA440 and a VM that is hosted on EXXi environment. I have both the firewalls on the same network. You can see the IP address here, which I have listed down in diagram. So what we will do is we will build IPsec tunnel between two devices, which is resistant to post-quantum attacks. One of the very first things that I will do is I will create a tunnel interface to establish the IPsec tunnels. We'll add a comment here, and next I will select the existing virtual router. In PA440, I should already have a zone that is already created. I'll select that for IPsec, and my tunnel interface is created. Next, what I'll do is I'll create the IK crypto profile. For that, what I'll do is I'll use one of the existing profiles that is already available. I can go ahead and clone this, and I will modify the name of this. I'll leave the ciphers, DH group, authentication, encryption as it is. The next option that we have to do is we have to go to advanced options and we have to select the post-quantum ciphers that we will use to derive this new key. So for this, we can go ahead with one round, or we can add additional rounds where we'll be able to increase the resistance of the new key that we are deriving using this additional key exchange. I'm going to use 3 rounds here. So the more rounds that we add, there will be a little bit of additional overhead on the IK packets. So what we'll do is we'll use only 3 rounds, and then we'll create the IK crypto profile with that. Next, we'll create the IK gateway also. Create a new gateway, we'll give it a name. I will select the interface also. Make sure the version is IK v2 only mode. Okay, my untrust interface is 1/8, so I selected that interface. PIP address 192.168.1.11, and I will give a pre-shared key also. And let me increase it a bit. Then we'll go to advanced options. Make sure that we enable PQChem cipher negotiations and also select the crypto profile we created. And also it's good to enable this IK v2 fragmentation. You can see something called PPK. That was the previous implementation that I mentioned earlier for RFC 8784. Now what we will do is we will go to the EXXI VM also, and there we will do the same steps. We will create the tunnel interface. So here this is a new VM, so I'll probably need to create the zone also. I'll create a new zone. Don't need to change anything. I'll leave them as it is. Next, I will create the IK crypto same way. I'll clone the existing one and I'll modify the advanced options in this profile. I have to use the same ciphers that I used on the other end. Let me just double check that. I used Kyber 768 for the round 1, and round 2 it was Bike L1, and then round 3 we used Prodochem 640 AES. Okay, all good. All the ciphers are matching. Next, here also we have to create the IK gateway. We give it a name. I'll select the interface. IP address, I have given it as DHCP, so I'm not mentioning the IP address here. I'll give the same pre-shared key. Here also make sure to enable the post-quantum key exchange option, and then select the right crypto profile and also enable IK v2 fragmentation. Now IK gateways are done. Next we need to build the IPSec crypto profile and the tunnel. So for this also what I'll do is I'll clone one of the existing profiles that is available. Clone is done. We'll modify the name. Authentication also I will enable as SHA-256. Let me remove the option for none. And I'll probably select 1 round for key exchange for the IPSec. I use Kyber 768. Okay, let's go with 2 rounds with the bike L3 also. Let me do the same thing on the PA440 end also. I'll rename the clone profile, add authentication also, and then modify the advanced options. Grab 768 and round 2 used bike L3. Let me verify that, yes, same ones. Next, we need to create the IPSec tunnel. So we'll select the tunnel interface we created earlier, and then IK gateway. We'll give it a name. Then I don't need to change anything there. I will leave everything as it is. Not mentioning any proxy IDs because I'm only going to establish the tunnel between the two gateways. I'm going to do the same on the other end as well. Select the gateway, select the right crypto profile. All good. Okay, let me commit the configurations on both the firewalls. We'll wait till the commit completes. Okay, we have both the commits completed now. So let me log into one of the CLI. And I can initiate the IPSec tunnel from here. I will use the test VPN command to initiate the IPSec tunnel. Okay, the IPSec tunnel is initiated. Let me just check this. It should be up. Let me verify. Yes. Negotiation is completed and the tunnel is up. And if we go inside, we'll be able to see more details. Okay, let me do that on the CLI itself, because in the CLI command we can see all the ciphers that was used for the negotiation. So we can use show VPN, IKSA, gateway, details. We can see that the algorithms that were used, including Kyber, Byte L1, Frodo, Kim, all of that. I can also use the command IKSA detail gateway. I can select that. Here you can again see the algorithms that were used for the proposal. And that's it. So you can use these commands to verify that IPSec tunnels are established with post-quantum resistant ciphers, and they have used the hybrid keys. Thank you very much.